So you know the important internal parts of the wings. Okay, so these two are the spar. This is front spar. This is the rear spar. Okay, front spar, rear spar. Then these elements are called wing rib. Okay, which gives streamlined body to the wing section. Then additionally we have a lot of stringers, wires, etc. and all. So here we are going to design this wing rib section, that is aerofoil shape. And the drips also, n number of designs are there. In the olden days, we use the truss type. Okay. Then additionally, we have provided the gusset so that to avoid the buckling. Okay, there will be additional layer, metal or wooden layer near the joints, so that to prevent the buckling we added. Then another type, it is a plywood with the holes. You know why there is a holes or gap? Just to reduce the weight. Okay. Now it may be composite nowadays. Like that, n number of designs are there. So just I'm going to design this gusset type wing rail. So I have used NACA. Sorry. I have used NACA 2412 aerofoil. So this is the profile first I'm going to draw. Okay. So the chord length is around 1000 mm. From that I'm going to create these two aerofoil profiles. Then internal spar and truss. So I will show the clear picture here. Okay, so first I'm going to create, so this aerofoil, the internal aerofoil. So only once I will make it, because other three aerofoil profiles are same aerofoil. So I'm going to use offset for the remaining two aerofoils. And the first aerofoil chord length is 1000 mm. Then this portion is the spar. Okay, here only we will insert the spar, front spar and rear spar, and these are all the truss. Okay, and this above portions and below portion as the gusset. So this design I am going to draw it now. So first I am going to make this aerofoil profile. So if you double click the Catia, you will get this product design, assembly design. Close that. Then you have to go to the start, mechanical design. Okay, sketcher. Just click OK. So the sketcher tool is already selected. It is in orange color. Now you can see, select the plane or planar face. So we can select any plane. For example, YZ I am selecting. Now we have entered into the sketcher tool. Okay, so that is the NACA 2412 aerofoil. We know there is no, what is it, single dimension to mention it. Aerofoil means it has n number of coordinate points. Okay, simply using this circle or ellipse or rectangular tool, we cannot create this aerofoil profile. Aerofoil will have the n number of coordinate points. So whatever the tool available here, it won't be sufficient. Okay, for example, if you use the spline also, simply we can create, but we don't know whether these points are properly made or not. Okay, so it is not possible to create the aerofoil using these existing methods. So what we are going to do, we are going to import the aerofoil profile directly. Okay, so for that, first step is, so once you open the Catia, as I said, there will be a product window. You have to close that product window. Then you have to go to the part design. Okay. So if you have any observation note, etc., you can note it down. First step is open the Catia, then close this product window. Okay, the default one is product window. Then open the part window. So you can see Catia V5 part 1. Is that clear?
Sir.
Okay, so this is the first step, very important step. Many students, they know how to create the coordinates, how to import, etc. and all. but they will forget to close the product. They forget to open this part. During the exam also they used to suffer. In hurry they will forget and they will waste their time. So don't forget, in the part window only the importing of points will work. Okay, this is the first step. So I have opened the part design in the Catia, minimizes. So next step, we need the coordinate point of this aerofoil. So we have to download that. It will be available in the internet. So NACA 2412 coordinates. If you type NACA 2412 coordinates, I have taken 2412. So if you can take any number of profiles, anything you want. See, the first website is airfoiltools.com. So most of the airfoil you can get it from this airfoiltools.com itself. You can see if you open NACA 2412 profile. So here they have given the coordinate points. Okay, so this is the leading edge point 0 and trailing edge point 1. Okay, 0 to 1. I'm sorry, 1 to 0 they are going. That is 1 to 0. That's why first column, if you see, start from 1, it goes to 0. Then again, from leading edge to trailing edge, it is going from 0 to 1. Like that, all the coordinate points are available. So you can take it coordinate points from this page itself. Okay, or another one website is there, that is UIUC aerofoil coordinate database. If the coordinate is not available in this airfoiltools.com, you can go for the UIUC airfoil coordinate database. So here what you are searching is the NACA. So I can select this N. So all the NACA profiles are available. Now you have to search where is NACA 2412, 241415, like that. A number of profiles are available. So here I am getting NACA 2412 dat file. Open it. Okay, same profile is available. Is that clear how to download? You can take it from airfiletools.com or you can take it from UIUC website. Okay, from here or from there, anywhere you can copy, it's up to you. I'm just copying the points, then save it in the notepad. In some browser it will automatically saved in the notepad. In some browser it won't save. In that case you have to paste it in the notepad. Is that fine up to this? Should I repeat?
It's fine, sir.
Okay, so now I got the coordinate points. Now we have to import the coordinate points in the Catia. Next step. So for that, so you have to go to the this PC, then where you have installed the Catia local disk C. Then I think in that program files 86, there you can find Dassault system. Okay, Dassault system in that B20, then Intel A, then code, then command. You can see the path. This is it clear or it is too small to see? This PC, local disk C, program files 86, Dassault system, B20, Intel A, code command. Is that clear? The path?
Yes, sir.
Okay. So in this command folder, we have one Excel file. Through that only we can import the coordinates. That file, the name start with GSD. Okay, I just type GSD. Now I am getting uh, 3 files. So GSD, some CAA, GSI create star, then GSD points spline loft from Excel, GSD points spline loft from Excel before V5 R12. So these two files are necessary. Okay, and here they mentioned one is there is no condition. It can be used for any Catia version, and the last one it should be used for before V5 R12. Okay, in the lab we have R14 and here I have R20. So all are latest version than this 2012 model. So this model is before the 2012 model. So we can take this second file gsd underscore point spline log from Excel. Is that clear?
Yes, sir.
So just copy the file. Very important. You should copy. You should not cut. Okay. If you cut and paste somewhere, then you will lose this file. Later you cannot import, etc. and all. You should copy this file. Then go to desktop. There you can paste it. Okay. So this PC local disk C program files 86 Dassault system B20 Intel A code command. There you type GSD. In that GSD point spline lot from Excel file, you have to simply copy and paste. Don't forget. Okay, so the file is here now. So using this GSD file only we can import it. Okay, not like you can open the normal Excel file. There you can paste this thing, and if you try to import it, it won't work. Okay, this file, Excel file, should not create it on your own. It should be copied from the Dassault system folder. Don't forget. Okay, here already some points are available. Start loft, start curve, then three coordinate points, end curve, end loft, end. Okay, so instead of these points, I am going to paste our aerofoil coordinate points. Okay, and these things are important. Start loft, start curve, and this end curve, end loft, end, it is must. We should not delete this. But here they mention only around 17 points, but we have more than 17 points. So better I will paste it right here. Later I can position it in proper place. Okay, start loft, start curve. Now we have to paste our coordinate point. Just copy and paste. While pasting, you can see in single column itself, both points are pasted. But we need those points in the separate column. So you can select this control, the down arrow. You can use text import wizard. Sometime if this text import wizard, if it is not available in this, you can go to data. Okay, there you can see that is this point should be selected. Okay, you can try from here also use text import wizard, or if it is not available, you can go to data, text to column, just fixed with next, next, next. That's it. We have converted that points into the two separate column. Okay, so it starts from trailing edge 1 to then leading edge 0, then again from leading edge to trailing edge it goes. But the trailing edge point, if you see, it is not 0. Okay, if it is not 0, it won't be a closed profile, it will be a opened profile. For example, so this is 0 point, this is 1 point. It is telling 1 is somewhere 0.0013. Okay, the profile will start like this, will come like this, it won't close. Okay, this 1 comma 0 means then it will touch this line, then it will be closed. So now it is the open profile. I'm going to make it as a closed profile. So instead of this 0013, I'm taking 0. Then only we will get the closed profile, because we know open profile we cannot proceed further or 3D etc. and all. Is it clear this step? So
Yes,
in
sir.
both, okay, in both trailing edge, I have closed the profile 1 comma 0, 1 comma 0. Okay. Now we have to place this end curve, end loft, end in its position. Now it should be like start loft, start curve, and coordinate point, end curve, end loft, end. But this Catia software is mainly for the 3D design. Okay, whether you are importing 3D design or 3D design, 2D design, we have to give all three coordinates. Okay, so if you try to import with the two coordinates, the software will show the error. So it need three coordinates, but as it is a 2D profile, then the 3D coordinate will be simply 0, right? So we have to specify all three coordinates x, y, z. So as it is 2D, the third coordinate point will be simply 0. Is that clear?
Yes, sir.
Okay. So now the files are coordinate points are ready. Now we can import it. So points are ready, and the main important thing is you should open the Catia, particularly in the part design. Some people they may not open the Catia itself; they will try to import it. Hmm? The system will think where to import. Okay, it will get confused. So don't forget you should open the part design. Then only you should try the importing. Okay, once it is made, then you should go to the view toolbar. Okay, after creating these points, go to the view toolbar. There you can find this macros. Okay, if you select the macro, this window will open. Here macros in, you select this workbook, then here select main, then run. Okay, so after creating, I went to the view toolbar, then macros, this window will open. Here I selected this workbook, and here I selected main, then simply run. Here it is telling if you want to import only point, you can enter number 1. If you want to import only the point and spline, you can import only 2. Or if you want to import all that, you can try the number 3. Better I will go for number 3. Then give OK. Now you can see in the box is moving down. That means it is importing. Now if you open that minimized Catia, you can see all those points. Okay, geometry from the Excel it is imported. Now for seeing it is like a small point, you know how to make it bigger using this fit all in tool from the view toolbar. Now the airfoil is imported. You know the Catia default unit is mm. Whatever you import, it will take it in mm. So see what we have imported, 0 to 1. Okay, that means after take this, the complete profile card length as 1 mm. Is it clear?
Yes, sir.
Okay, so software created the profile for 1 mm. That's why the profile is not smooth. Actually, the profile is smooth only, but due to the visualization issues in the software, we are seeing like a some sharp edges and all in that smooth airfoil. Okay, so we imported the profile, but this profile contains point, line, etc. and all. What we need is the only line. Okay, as I already told you, we should not create the points unnecessarily. We need only this line. So what we have to do, we have to copy only this line. For that, we have to go to the sketcher because there only we can do line, point, copy, etc. and all. So I'm selecting the sketch tool. Then we have to pick one plane. So we should take the plane which is parallel to this profile. Okay, this XY plane I am taking. That only parallel to this profile. Now we enter into the sketcher profile. Is that clear? Say first I imported, then I tried fit all in tool so that I could see the airfoil profile. I don't want these points etc. and all. We can delete it here. If you try to select this point and delete, everything will be vanished. See, it is asking delete all children. Everything will be deleted. So we cannot delete the point alone here. So for that purpose, I'm going to copy only this line. Okay. We know all these line, point, operation and all, we can do it in the sketcher only. So select the sketcher tool, then select the plane which is parallel to the profile. Now in this operation toolbar, the last one is project 3D elements. Okay, we can project any point or line using this option. So select the tool. Which one we want to project? Only this line. Okay, not the point. So select only the line. Now see the line got projected. Okay, is it clear? Should I repeat?
Yes, sir. Repeat one.
Shall I repeat?
Yes, sir. Repeat.
Sure, sure, sure. Okay. Okay. The profile is imported. Then go to the sketcher, select the parallel plane so that we can project only the line. We don't want the point. Then in the operation toolbar, the last one is project 3D element. Okay. Using that, I can project this point or line, but here I need only the point. Now see the line alone projected. It is in yellow color. Now I am copying this line alone. Okay. I have projected and I copied. Now exit the workbench. Okay. From sketcher to part I am going. Okay, so this line alone I projected and I copied. Again I came to its part design itself. As I already copied, I don't want this line or points. Okay, you can right click here and delete it, but I prefer you can right click in this geometry from Excel in the tree and delete it. Now see everything is gone. Okay, but already we copied the profile. Which plane we copied? I think in the XY plane we copied. Okay, go to the sketcher, simply control V. That profile we got it. Is that clear?
Yes, sir.
Okay, so you should copy, then you should delete it from the tree, then go to the same plane and paste it. As I said here, okay, the card length is just 1 mm. So even though the profile is smooth, due to the visualization error, it is coming like a sharp edge. Now we will increase the scale. Okay. So here they mention airfoil should be of card length 1000 mm. Okay. So in this fourth tool, if you expand, you can get translate, rotate, scale, mirror, offset and all. So now we are going to increase the scale. To select the scale tool and select the profile. This profile only I want to increase. Then it is asking some reference point. Okay, here you can see. Select or click the scaling center point. About which point we have to increase the scale. I am taking this leading edge. Okay. Now it is asking what is the scale value. It is of 1 mm. I want to increase to 1000 times so that it will be 1000 mm. Now you can see fit all in. Now this is the proper Naka 2412 profile for 1000 mm. Okay, you can see it is 1000 mm. I will repeat it. It just came out. I'll repeat the procedure then. I'm taking, sorry, I'm taking parallel plane and project the line alone, then copy that orange color line alone, then exit the sketch, then delete these imported points. I don't want that. Now select the same plane from where we copied. See, while pasting, you should go to the sketcher because we copied from the sketcher only. Some people, what they will do after deleting it, they will try to copy in this plane in the part design itself. Okay, but it won't work because we copied the profile from the sketcher window. Then you should go to the sketcher window, then only you can paste it. Okay, and it is of 1 mm. So using this scale tool, I'm going to increase the size. First select the profile, then select the center point, reference point. Then here you can give the scale 1000 mm and OK. Okay, in that you can see. So in that window you can see duplicate mode is on. Okay, so duplicate mode is the original profile, also the modified profile will be available. Okay, even though here we don't want the original profile, always select with the duplicate mode. Later we can delete it because in some cases if you unselect this duplicate mode, the scaling will not work. Okay, but while importing, You ensure the duplicate mode is on. With that, you give the scale so that you will get both profile. This is the original profile for 1 mm. This is the modified profile for 1000 mm. Actually, now we don't want this 1 mm profile. We should delete it. Okay, you should not forget to delete it. Otherwise, later it will create the issues. Is that clear?
Yes, sir.
Yes, sir.
Okay, so this original profile I deleted. Then fit all in. Now you will get only this modified profile, and there is no what is it? Individual dimensions we can give it for this airfoil. As I said, once you create one profile, sorry, so it should be in green color. Okay, otherwise it can be mistakenly moved from here and there. Okay, but here what we can give maximum, we can give the distance, that alone we can give. All other coordinate points we can't define it. So only for these complex shapes you can use the fixed tool. Okay, if it is a circle or ellipse, etc., other designs and all, you should bring it to green color by giving the proper dimensions. What is the length, dia, radius, etc., and all. But only for this airfoil profile, simply I selected this curve. The first dialog is first box is enabled. Constraint defined in dialog box. There you have to give fix. Okay. So now airfoil, first airfoil profile is created. Now we have to create remaining two airfoils. So same airfoil, they have mentioned offset distance of 30, inner one, then the last one offset of 5. Okay. So we have to use offset tool. So select these two profile. You know, multiple select lines if you want to select. Press Control, then select the lines. Then offset tool, it is in the operation fourth toolbar, the last one. So profile is selected. Now we have to define the offset distance. It is 30 according to the sheet. Now see, it is offset to 30. It is in orange color, that means it is selected. So simply I can fix it for the selected lines. Then select this airfoil profile, another one offset. This time they mentioned it is 5 mm. This also, it is in orange color, already selected. You can simply fix it. Is it clear? Should I repeat?
Clear,
Hello?
sir.
No, sir, it's fine.
So, okay. So three profiles we created. Now we have to create this vertical lines and inclined line. Okay. Actually, these hatch lines, that is difficult to create in the sketcher. Actually, these hatch lines and all, we will create it in the final drafting design. Okay, this is the drafting of that model. So we won't create this hatch lines. We will create the profile like this, the bottom one. Okay, it will be the just blank spaces. There won't be any hatch lines. Okay, like this we are going to create it. So hatch lines we will create it in the final drafting, not here. Okay, first I can draw this two spars. Okay, these two spars I can create it. So we have used the reference line here and here. You can see the reference line. So the reference line is from this inner airfoil leading edge to 200 mm. Then from this line to this line, it is another one 500 mm. So first step, I'm going to create two reference lines. One is 200 mm from the leading edge. Another one is 500 mm from this first reference line. Then I can go for this vertical lines, spar lines. And they mentioned the thickness is totally 80 and it is symmetry. So one side it is 40. So first we will create this one. So you know in the profile toolbar, here you can find the reference line. So first create a vertical line. It is auto constraint. Okay, it won't affect. And if it is blue color, that means it is vertical. So two lines are created. Now we can give the distance between this line and this inner leading edge, inner airfoil leading edge is 200, and distance between these two reference line is 500. Now we can draw the spar design. But I will take the line. Okay, just double click so that I can draw the lines continuously. So it is touching the second airfoil. Okay, now I'm just drawing the lines. Later I will give the dimensions. See, while creating, there should not be any auto constraint, and you have to ensure it is just vertical. Okay, the blue color line. Okay, so 4 lines I have created, and all the lines are coincide with these lines. That's why O symbol. Okay, it should coincide. So you should not create it like this. So without touching, you should not create, or even it should not cross the line. Exactly, it should coincide with the existing airfoil profile. Like that only you should create it. You should see this, the O symbol, coincide symbol with this line. Okay. So they said the complete thickness is 80, and from the reference to this point is 40. That too we can change it. What we can give? I can give symmetry for these two line with respect to this center line. So using this first one, I can use symmetry. Then I can define the distance between these two. 40. Sorry. Okay. So I could give 80 between these two line and 40 between these two line. Instead, I have given symmetry and 40. So software will take this side also 40. 1 minute. Ravi sir? I'm the lab sir. Okay, 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 sir. Okay, so similarly, here also, here maybe here instead of symmetry, I will give the dimensions. For example, from here to here, it is 80, and from here to here, 40. In this way also you can give it, but you can see by giving symmetry, we can simplify the profile. There is only one dimension. It is easy to understand, but here 2 dimensions. Okay, so we should reduce the number of dimensions as much as possible. Then only it will be a good drawing. So manufacturer can easily understand without any confusion. Okay, so the spars are created. So the spars will be inserted in this space. So these lines should be deleted. You can see the profile. The spar is inserted here. There is no interlines. So to delete that, again, this third tool, if you expand, you can find the quick trim. Okay, so in operation toolbar, third one, if you expand, you can see the quick trim. Just double click so that I can continuously use that. I'm simply selecting these lines and all. Okay, I deleted. So spars are ready. Now I have to make the truss. Actually, these lines now it becomes white because we break the line, right? So later we can fix this. Okay, at last we can fix this. Now also you can fix, otherwise it will move here and there. First one, fix. Now everything is fixed. Now we can go for the truss type inclined lines. First we will take this line, inclined truss. Okay, one line is touching here, and another line it is coincide with this axis. Okay, so first we will draw this line. One end is just in the axis, another end is just in this corner point. Then we can draw another one parallel line, and they have mentioned the thickness is 8 mm everywhere. Okay, so there is one inclined line. One end is from this corner, another end is, you see, it shows O symbol. That means the line is coincide with this airfoil profile, and according to the dimension, it should coincide with this axis also. Is that clear? The auto constraint. Is it visible? You see, now it is coincide only with the airfoil. If you keep on moving, now it is coincide with the axis also. Okay, so both side is restricted, so it is in green color. Now we can draw another one parallel line. That line should be parallel and should coincide with both airfoil profile. Then we can define the distance between these two lines. It is 8. Okay, so in the leading edge it is finished. Then in the center part, so they mention this vertical line 140 mm and this vertical line that is also 140. Okay, so first I'm going to draw these two vertical lines, then we can draw these two parallel lines, then these inclined lines. Okay, simply here and here it is joined. I'll try this now. The worksheets are already uploaded in the GCR. You can open and check it if you want. So I have to draw two vertical lines. It should coincide with the airfoil profile. Then distance between these two is 140. Similarly, here also it is 140. Then I will draw the parallel lines. Now you can draw the inclined lines. You see it is trying to create, okay, coincide with this point or this point, something else it is trying to create. Okay, so you should pick the point somewhere where we don't get the any constraints. So everywhere you can see there is a constraint. Okay, here I don't get any constraint, so I'm selecting here. But now it is not parallel. Okay, in that case, you can select these two lines. You can give parallelism. Okay, for example, see here I'm drawing one line. First line is no issue. Second line also, while creating, see I'm automatically it shows parallel symbol in the center coincide in the line. Like this, if it is coming, it is not an issue. Or if you couldn't pick, it is getting some other parallel issue means that is auto constraint issue means you can select it anywhere. Then select these two lines. You can give parallelism. Okay, both way you can give it. Okay, you said it is completed. Only the last one is remaining. So one vertical line drawn 350 mm from the trailing edge. Okay, the remaining lines are same. So one vertical line, and the mentioned distance between the trailing edge point and this one is 350. Now another one parallel line. That is right. An inclined line. That's it. See, I have made it as a, that is I have given all the constraint. Still it is in white color. Okay, if it is in white color, what you have to do, you should pick the lines and try to move it. Okay, now which constraint is missing? How to convert this into green? Any idea? Hello, are you there?
Yes, sir. Yes.
Yes, sir.
Now how to arrest this motion?
Yes, sir.
How to arrest? Any guess?
Fixing.
Sorry, ma? No, we
Sir,
should not
should
use
we
fix.
fix the point?
Yeah, how to, where to fix? So what happened? This line, it coincides with this aerofoil, but according to this profile, the line should coincide here, this intersection point. That is, with this line also it should coincide. That is missing. Okay, so I can select this point and this point. You can give coincide, then it is fine. Okay, so this line should coincide in this intersection point. Okay, but previously it was coincide only along this airfoil profile, so it is moving along this line. Now it won't move, it is in green color. That's it. Final.